Good morning, everyone. Okay. Good morning, everyone.
Good morning.
Good morning. How did your homework go? Did you guys do the homework from the book?
Yeah, it went pretty well.
Okay. Anybody has any question about it? The way that we start the class every time, because most of the learning, as I said, will be from you doing the homework that I assigned from the book. And this is really where all your learning will come up. So every time we start the course, every time, the first thing I'll ask you which problems you had difficulties with. And we go over it very, very slowly. So you guys will have a good grasp of the material. Okay, so don't shy away from asking questions at all. If you're hesitant about anything in your understanding, just let me know. All right. So again, I'll ask the same questions. Any problem gave you any difficulties? Anyone? So I'll give you a minute to look them over since it's the first time we start this way. Okay. Right, so let's start it. I will pick up one of them if you guys don't, and ask you questions about it. So, but first I want to mention a new word, which is the domain of a function. We're gonna have, today, we will have a definitions, and later on we will alter it a little bit. But for us, this is the domain for us, the domain of a function. Okay, so I will sort of on number 5. Sure, thanks. Thanks, I will do it. I'll definitely do it. The domain of a function. So let f be a function. It means be a function. What does it mean to us? Whenever you have a function, you have to start to really having a picture in your mind. It means I have bunch of input. So we have bunch of variable things that change. And we have a rule that to each input, so we have an input and we have a rule. To each input is gonna associate exactly one output. So there is this kind of machine working that us. The domain is nothing more than all the input value. The domain is the set, is the collection of all the input values. And every time we're going to do a problem today, I will be asking, what's the domain? So we get a feeling for it, set of all input values. And how do we find the domain? We read the problem, and the problem will tell you, for example, let f be the function that is assigned to every US citizen the number of letters in their first name. So if the example we took last time, so to every US citizen, the number of letters in their first name. So the input here are the US citizen, the output, the number of letters. The domain in this scenario will be all the US citizens. So it's a huge set. There are a lot of things, object in it. Every US citizen is part of the domain. Means where those input? What are they? That's what we call the domain. So with this in mind, I'll go over number 5 and we analyze it, and I will ask you the question, what's the domain of this function? So let's look at number 5 from the book. Okay. Number 5. Let me pull it up. All right. So this is number 5. You should have it in front of you. It's totally from the book. 20 people are standing in a line. Okay, back to the line. And let A be the set 1, 2, 3, up to 20. And f is the function that to each number n in A, so A is my set, to each one of them. So when they say to each number n here is the variable that represent, which is symbol that represent every object in A. So n represent 1, 2, 3, 20. So instead of telling you what f does to 1, what f does to 2, what f does to 3, which is of course, tedious, they tell you what F does to any element. So N represent any element of A. And what does it tell you? It assigns to each number N in A, to each number, the first letter of the first name of the nth person in line. And then for each item below, indicate the type of object that the item is. So is it object a name, a person, a function, etc. Okay, so we read the problem again one more time, and we understand what the function is doing, and then we come back and answer every one of those. So what's the function is doing? All right. First, what are the input here? What is the function doing? So it's assigning to every element in A. So A for me is this. That's really what my A. So it's bunch all the way up to 20. So one way to think about it, that's my A. What's the function doing? To every element in A, to every n in A, assign the first letter of the first name of the nth person in line. So imagine those are people in line. I mean, they should be horizontal, but you guys are smart. So that's the first person in line, the second person, the third person, and so on. And that's what it does. To every person here, it does the following. The first letter of the first name. First letter of the first name. So this one, the first letter of the first name of the second person in line. The first letter of the first name of the third person in line. So that's really my rule is doing. So to 1, the first letter of the first name of the first person in line. To 2, the first letter of the first name of the second person in line, and so on and so forth. Okay, whatever, I'll read it. So now here's my question. What is the domain in this problem? The domain are all the input value. What are the input value in this particular scenario? What are the input value? It means what are the thing, the object where we're assigning something to. Now I go back to you. What's the domain in this problem? It means what are the inputs? Are they, I don't know, what are the input? I'm going to erase this because that's confusing. I'm going to keep that only.
Is it the 20 people that are standing in the line?
Not quite.
Is it the
Not
first letter of?
Quite. That's okay. I want all of you. What? Not quite. They are not the people. They are what?
Is it the actual numbers?
Exactly. They're the actual numbers. The input are the actual numbers, because how is the function working? It starts with the set A, and A has the numbers 1, 2, 3, 4, up to 20. And F is assigned to 1, that's the input 1, the name of the first letter of the person sitting the first spot. It is assigned to the number 2, so we're assigning to 2 something. The first letter of the first name of the second person in line. So what's taken for input are 1, 2, 3, 4. So the domain here is actually the numbers 1, 2, 3, etc. up to 20. Those are the input. So when I'm going to write F, what I'm going to put here is the number of where the person is in the line. These are my input. So how does this function work? So if I write F of 1, what is F of 1? These are my input. F of 1 is the first letter, that's how this function is defined, of the first name of, when I put this in red, that's my input, of the first person in line. That's how the function is. So my input are 1, 2, 3. To 1, I'm assigning the first letter of the first name of the first person in line. What is F of 2? Is, so that's the output, that's what I'm going to assign to 2, the same stuff. First letter of first name of second person in line, and so on and so forth. So my domain are 1, 2, 3 up to 20. These are my input, and my output are the first letter of the first name of the person in line. So with this in mind, I'm gonna go back and ask you questions that are assigned. What type of object is f of c? What type of object? It means, is f of c a person? Is it a letter? Is it a number? What is f of c?
Would that be a letter?
It will be a letter, exactly, because what is f of c? Is it my input or it's my output in this problem?
Output.
What?
It should be the output.
Exactly. Why it's the output? It's f of c. What's go inside is the input. F of c is what we assign to c. So that's my output value. So f of c is basically, so f of c represent what we assign to c. So it's what we assign to c. Means f of c is an output value, because it's f of something is an output value. And in my problem, what we assign to every 1, 2, 3 is the first letter of the first name. So f of c is a letter because it's an output value. It's what we are assigning to c. Question number 2, B. Okay. B is the following. Okay, I'm going to try to keep both here. If f of c is D, what type of object is C? I give you a second. Ask yourself, what type of object is C? What is C? Is it an input? Is it my output? And then I will pick one of you to answer the question. Who's ready? Who think comfortable before I pick?
I think I know.
Yes, go ahead.
F of C. So the C would be the input. C alone would be the input.
Absolutely correct. So it is what? Is it a number? Is it a letter? It's what?
It would probably be in this case the
C is the input. Absolutely correct. So C is a, think about the function again. What's the function doing? It's sending 1 to the first letter of the first person in line, 2, the first letter. So the inputs are what in my scenario? Those are my input. So is it a number? Is it a letter? It's what?
Numbers.
Absolutely, it's a number. What about D? What about D? A letter or a number? Think about it. Think about it. What about D? Is D an input or an output here? Watch what's D? D is F of C. It means D is what? A letter, an output or an input in this problem?
an output.
An output, because it's what we assign to C. And the output in my case are the letters. They are not the numbers. So D in this context, they're not asking you about D, but we should understand D here is F of C. It means D is what we assign to C. So what we assign to C is a letter. So C is the number. And what we assign to it, it means F of C, sorry, C is a number. And what we assign to it is a letter. So here C a number, D is a letter, because it's an output value. Now, again, the same question. What type of object is f of 4? A letter? A number? I don't know. What can you say?
I'd say a letter.
Because you're
Because
right.
it is the full output.
It is because I can't hear you.
Oh, it's because it's the output.
It's the output. So what does f of 4 represent? It's exactly what your classmate is writing. It's the first letter of the first name of the fourth person in line. That's what f of 4 represents. The input is your position in the line. So the input is where the person is standing in the line. So this is the fourth place in the line. And f of 4 is the first letter of the first name of the fourth person in line. Very good. Now, D. Read it carefully. Okay, I'm gonna pick those who are not showing me their faces. Peyton. Peyton Sales, you're with me?
Hello.
Yeah, go ahead. What do you think C plus 3 is? A number, a letter? Ask yourself again.
A number.
Because. You're right, because.
Well, besides it just being a number instead of a letter, it's just like the value of it. So it's represented as a number, not a letter, but it means basically the same value, correct? Like,
I have to be more
um,
precise because I have to understand you. It is a number. You're right. The way I want you to think about, is it an input or an output? The C plus 3, is it an input or an output in the C?
an output.
Are you sure? What goes inside the parentheses are what? What goes inside the parentheses?
The input.
Those are the input value. Okay, that's the input. F of what goes is the output that corresponds to this input. Are you with me?
Yeah.
Okay, so we have to be very, very careful in the notation of the function. So when I write f of C plus 3, I know they are confusing you because you're writing C plus 3, but that's really the point. I want you really to understand what it is. This piece is the input, and f of it is the output that corresponds to C plus 3. So here they're telling you, okay, the function will stand C plus 3 somewhere. So C plus 3 has to be the position in the line. That's where my input are. And f of C plus 3, that's the output. And this is the first letter of the first name of the person who is C plus 3 in the line. So C plus 3 is an input. So C plus 3 is a number. All right. So before we move on, let me ask you the following question. Suppose I write this statement, f of 15 equal L. I'm still working with the same problem. Who would like to interpret this sentence for me? So I'm gonna pick Taylor. You're hiding your face, but I can see your name, Taylor.
Yes.
Go ahead. If I write, this is the same function, f of 15 equal L. What information am I giving you?
That you're gonna put 15 in for something.
If it spits out L, what does it mean? It's the same function. Remember, the function tells you the following. These are the people put in line 1 up to 20. Okay, and the function sends to everyone the first letter of the first name. That's what f does. So if I write f of 15 equal L, what does this mean? Interpret this. What does the 15 represent?
15 would be the 15th person in line.
Right, it represents the 15th person in line. What does L represent? The output.
A letter?
Letter. The letter of what? Now we're focusing. The letter of what? It's the first letter of the first name. Of the 15th person in line. It means that if the 15th person in line, his name, his first name should start with L. That's really what it's telling me. It means the person who is 15 in line, his first name starts with L. So he could be, I don't know, you just give me a name that starts with L. I cannot think of any right now.
Logan?
Logan. No, it could be a Logan. Or it cannot be a Peter, for example. It has to be a Logan because the first letter has to be L. So interpret this, it means you have to understand 15 is the input. What does the input represent? Represent where the person is in line. And F of it is what did we assign to this person who is 15 in line? We assign the first letter of his first name. It means whoever is in the 15s, his first letter starts with L. So he could be a Logan, for example. All right?
Okay.
Okay, that's crucial to understand. Very good. So this is for number 5. Just you guys go over it again so you understand this. Okay, so now, all right. So what other questions do we have? Can we also go over number 7, D and E? So I will look at number 7 and then we will proceed. So let me look at number 7. Sorry. What is number 7? My apology, I'm looking for number 7. It's probably staring at me in the face that I can't see it here. So, sorry, it was right there. All right, so number 7. Good. Let's read it carefully. So the table below shows the average monthly rainfall in inches for a town. So it tells me in a town, let us see Munster, for example, the average rainfall. Look at the table and answer the questions below. Explain completely. Okay, so this is a table. So it tells me that in January, the average monthly is 2.1. February, the average monthly rainfall in inches is 1.3, and so on and so forth. Now we have a function, it means we have a rule. And this rule is assigned to every month the average monthly rainfall for the town. Is F a function? Now first, yeah, is F a function?
Yes.
Yes, there is nothing. So the January is not assigning to one month 2 different averages. To every month is assigning only one average. So the output is unique. Okay, before I answer B, I want to ask you the following question. What is the domain of this function? What are the input of this function? F is assigned to each month the average monthly. So the way you have to picture this function is like this. It is assigned to every month, so that's, it assigns the average rainfall. Okay, to every month, the average rainfall. So what's the domain of this function? It means what are all the possible input that the function is taking? Exactly, each month. So the domain, if I want to write it in details, it's January, February. So these are the input, March, etc., December. So there are 12 objects in the domain in this particular problem. Okay, so the domain are all my input. Those are my inputs. All right, now I know that your classmate did not ask for that. What is F of April?
Is it 0.7?
Right, F of April. April is here absolutely 0.7. Is there an N such that F of N is 1.9? Now, 1.9, is this an output value or an input value? Back to you.
An output value?
Output, because it's F of N. So the question now, I want the output to be 1.9. Can you give me an input, which is a month, such that the output 1.9 quickly?
August.
August.
August. So N is August. Very good. Now, are there two different months with the property that f of A equal f of B? It means, can you find 2 months? that have the
January,
same
September.
January 2.1 and September. Absolutely correct. They both have the same output of 2.1. Maybe there are others, but that's enough. So A could be January, and the answer is yes. And B is what you guys said, September. Very good. E, is there a month with the property that f of C, it means the average rainfall in C, is larger than the average rainfall for every other month? Means, can you find a month where the average rainfall is larger than everybody? It's basically which months have the largest amount of rainfall. So November, somebody, Rick is telling me November. It makes sense because that's the largest amount of rainfall. So if there is C that has this property, yes, C is November. Because C is an input value. So C is November because in November, it rained more than any other month because it has the largest amount of rainfall. Okay. For D, no, two, because I tell you, are there 2 months? Yes. If the question is find all of them, then you have to give me all of them. So you have to read the question very carefully. All right. Very good. Now the other problem I would like to go over also clearly in this section is number 9, and then we proceed because this is basically it's crucial that we know how to work with functions. So I will look at number 9, even though you guys didn't ask me, but I have to because it's important. So far we're working with functions, input and output, and all our functions were given verbally, you know, like story problems. Number 9 is starting to give us function where the output is given by a formula. So let's look at number 9. Let A and B be the set of all real numbers. So when I say all real numbers, we mean all of them, 1, 1/2, everything. F is the function that assigns that to each element in A, it means to every number, it assigns 3x squared plus 5. In other words, way of writing is that f of x is 3x squared plus 5. So I have a function which is given by f of x equal 3x squared plus 5. So in other words, I have a rule that if you give it x, x is a symbol for everything in the domain, it spits out 3x squared plus 5. That's really what my rule does. So whatever you give it, it spits out 3 times what you give plus 5. Right. Question number 1. What's the domain of this function? I want you to read the problem. What's the domain? What are the input values here?
Negative infinity to infinity.
Exactly, all possible numbers, because the problem is clear. The problem tells you that f is assigned to each element in A. But what's A? A is all the real numbers. So the domain here, the input, are all possible real numbers. That's really what the domain is. Now part A, I will not do all of it. I will just pick 2, for example. F of minus 1, because this is the part I'm sure all of you can do that. What is f of minus 1? So minus 1 now is an input value. What does f do? Take 3 minus 1 squared plus 5. Now minus 1 squared is 1. It means 3 plus 5, which is equal to 8. Very good. Now I will pick another one. I will do C. What does f do to a half? A half is a number. It's 3 times a half. That's what it does. Square it plus 5. Okay, let's compute this. So it's 3, that's multiplication. 3 times. Now what's a half square? Half square means a half times a half. Now, how do we multiply fraction? We multiply the numerator, 1 times 1, over, we multiply the denominator, which is 4. So it's going to give me 3 times 1 over 4 plus 5. All right. What's 3 times 1 over 4? 3 times 1 over 4, it means 3/4. It means 3 over 4 plus 5. And now we're going to find a common denominator. So we can simplify this. So common denominator is what? Quickly. What's the common denominator? Are you with me? Matthew? Common denominator. So if I want to write this as one fraction, I need a common denominator. What's the common denominator here? 4. So 3 over 4. So now if I have to find the common denominator, I have to multiply this by 4 divided by 4. And once I do that, I can combine the numerator. I get 3 plus 20, which gives me 23 over 4. And we're going to keep the answer as a fraction, just so that we can a little bit practice our algebra. All right? So that's f at 1/2. Now let's do some more problem. G. The question is the following. If t is any number, determine what f of t is. So we're still working with the same function, 3x squared plus 1. If t is any number, what is f of t? All right, I would like to answer this question. Nick Burr, what is f of t? Remember, what does t do? What does f do? Whatever you give it, where does it take it to? 3 times what you give it squared plus 5. That's the rule. So if you give it -1, it will take it to 3 times -1 squared plus 5. That's what the rule is. You give it 5, it takes it to 3 times 5 squared plus 5. That's what this function does. So what is f of t? Nick Burr. Don't be afraid.
So do you just want me to like assign a value to t?
No, I don't want you to assign. We have to do it a bit symbolically. I want you to keep t in your answer.
Oh, so wouldn't it be like 3t to the second and then plus 5?
Right. Exactly. Okay, they want you to keep t. They want you to keep it symbolically because we have to develop this thing. Are you with me? Okay, now I keep going. Is there a number c such that f of c equal 53? If so, find it. What are they asking for here? What are they giving us and what they are asking us for? Can you find a number c such that f of c equal 53? What are they asking us for? And what are they giving us? So I'm going to rewrite the question here. Question is, can we find c such that f of c equal 53? What are they asking us to find? Nick Burr, I'm picking on you. Sorry. What are they giving us? What do they want us to find?
Find c.
Okay, so is it an input or an output?
C is an input.
And what are they giving us?
Um,
What does 53 represent? 53 represent 53. 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 53 represent 53.
I don't know. I didn't have the question in front of me.
Okay, this is it. Can we find a C such that f of C equal 53? So 53 represent what?
Oh, well, yeah, I know the output, but
That's the output. And what do we want to find? The input. That's 10 to 53. How do we do this problem? Now you can guess. So 53 is an output and I'm after the input C. Can I find the C such that f of C equal 53? How do we answer those questions? We answer it as follows. It means we need to find a C such that, what is f of C? F of C is 3 C squared plus 5. This is f of C. So the question is, we want to find the C so that when I plug in the C into the formula for the function, I get 53. So the problem now is really to solve for C. That's really what the problem is now going to be about. So when your function is given by a formula and they give you the output you want the input, it's really boiled down to solve an equation like this. So now we have to solve for C. Now let us solve. How do we solve? We don't want to guess, we actually want to solve because sometimes it's hard to guess. So how do we want to solve? I have 3C squared. To solve it, I need to isolate my C. How shall I isolate my C? Let me pick. McKenna, how do you want me to isolate my C?
Divide by 3.
No, not yet. Look at it very carefully. Madison? How would you do it?
Subtract 5.
Right. First, to isolate it, we need to subtract the 5. Step number 1. So we want to solve. So subtract 5. Then what do we get? 3C squared equals, so I'm going to take away 5 from both, 53 minus 5. So this would give me 3C squared equal. Okay, 53 take away 5, we get how much? 48. Now, once we isolate it, now we divide by 3 both. So divide by 3. And this will give me C squared equal 48 over 3. Okay, so we have to solve for it. We really have to solve for it. So now this will give me that my C squared equal 48 over 3. 48 over 3 is how much?
16.
60. So that's the C squared. So what is the C? Remember, we're solving for the C. We're solving for the C. So when we plug it in this formula for the equation, it gives me an output of 53. So if C squared is C, what is the value of C? Back to
You would take the square roots of both C and 16,
okay,
and you would find that C equals 4.
Square root of 16. So it's going to give me C equal to 4. Okay, we're almost correct, but there is something missing. Who would like to fix it?
Doesn't it equal plus or minus 4?
Right, it's the plus or the minus. So it's the plus or the minus. Because, why? Because if I plug in 4 squared, I get 16. And if I plug in minus 4 for C, when I square it, I also gonna get a 16. So my C is plus or minus 4. So now let us recap a little bit. So now the question is, can I find C? So now let us recap. You don't have to write this. So can I find C such that f of C is 53? So how do we solve those problems? So it means that they want to find the input that spits out an output of 53. It means they want me to say, okay, what is the value that I should put for C to get 53? So the way we do it, we set 3c squared, and we solve for c. That's how we solve those type of problems. Right? Now, let us check. Is my answer correct? How can I make sure that my answer is correct? Okay, now we're done. We found that 2 values of C will give me 53. But let us say I want to check myself. You know, I don't know, am I right? How would
Plug
I check?
in 4 for C.
Right, where?
3 times
Right,
4
I'm
squared.
going to plug
plus
in 3. And I check. Am I getting an output of 53? If I'm not, it means I'm goofing. That 3 times 16 plus 5, right? Now 3 times 16, that's a 48 plus 5. It is 53. I am fine. So F does send 4 to 53. But now I had another value. I'm checking my answer now. Plus 5. Again, will this give me the correct answer? Very good. Minus 4 squared is minus 4 times minus 4. Minus 4 times minus 4 is also 16, which is 53, correct. Okay, so sent 2 values, plus 4 to 53, minus 4 to 53. Okay. Now I would like to do, which one? I would like to do number J, because it's also very important for us, J and K. So these are the 2 questions that definitely I would like to address. So we're gonna do J. So J tells me the following. So I still have my F, thus take an input X to 3x squared plus 5. That's still my function. J is telling me the following. If t is any number, find an expression for f of t minus 1. At this stage, we are dealing with function in a bit abstract way. How can I do that? What do they want me to do?
Plug in t plus 1 for the x.
Right. It means wherever there is x, wherever there is an input, my input now is t minus 1. That's what I plug it in. Plus 5. Okay, that's really what it means. So we're working with function a little bit in an abstract way. Now let us evaluate this expression. What's t minus 1 squared? All right, I'm going to do it to the side to emphasize. What's t minus 1 squared? It's equal to t minus 1 multiplied by t minus 1. Okay, and let's evaluate that. It's equal to what? I distribute t times t, t squared, minus t plus 1. So this will give me t squared minus 2t plus 1. So if we want to evaluate, which is I will actually expect you to do, so this will give me this quantity become t squared minus 2t plus 1 plus 5. And now I want to simplify this expression. So this will give me, I distribute again, 3t squared minus 3 times 2 is 6t plus 3. So I distribute the 3 and then I add 5. Finally, this would give me 3t squared minus 6t plus 8. Okay, so find an expression for f of t minus 1 is basically my input now is t minus 1. And the question is find an expression for it. So it really boils down to plug in t minus 1 for x. Right? Okay. So for next time, I'm going to assign number 9 again, and I want you to finish it. For those who didn't do that, crucially, very important for you to finish number 9. So I'm going to assign it again, and I want you to finish K and J very well, and you will be tested on it. Okay. All right. So today we are still working with function, and we're going to talk a little bit about function. I mean, we're not going to change the scenario at all. We're going to talk about the graph of a function. So section 1.3. Graph of a function. So functions so far, okay, these are those rules. So you give them an input basically, and they have to give you exactly one output. And the way the functions we gave them to you is first verbally. So let f be the function that is assigned to every US citizen the number of letters in their name. That's one way. Second way function will be given to you is a formula, like the one we did a minute ago. So let f be the function that take in input x to 3x squared plus 5. So the rule is whatever you give it, spit out 3 times what you give it squared plus 5. So that's another way the function will be given to you. A third way the rule will be given to us is by a graph. So functions where the rule is given by a graph. So functions given by a graph. Okay, what does I mean by that? What does it mean, the graph? So sometimes we have a picture like this. And we tell you the following. F is given by the graph below. So it means that we have a graph. So we have something like that. Like a picture. I mean, nothing more than that, like a curve. And I'm going to put a little bit some numbers here. So I'm going to put -2, -1, 1, 2, 3, and let us say 5. I'm not going to put any numbers here. All right. What does it mean, the function given by a graph? First, it means the following, that on the horizontal axis, we're going to put the input values. So the input values are always on the horizontal axis. Okay. But the question is, how does a picture like this gives you the rule? What does it mean, give you the rule? It means 1. What is f of 1 when we have the picture? So the rule is the following. If this is 1, what is f of 1 graphically? F of 1 is the following. You take the vertical distance from 1 till you hit the graph. You take the vertical distance from 1 till you hit the graph. You hit the graph here. What is f of 1? F of 1 is this distance from here to here. That's how a function is given by a graph. So it's given by the input will go on the x-axis, and the output is the vertical distance from 1 till you hit the graph. So this is what f of 1 is. So it's from here to here, how much you have. So this point here has for coordinate 1, the input is always the x component, and the output is the y component. So basically, I didn't put on purpose, I did not give any scale on the y-axis. This is where the output goes. So that's really what f of 1 is. So this is the first is what the input are, and the second coordinate is the output that correspond to this input. So whatever number you get here, that's your f of 1. This is how the rule is given. So for example, if I want f of 2, okay, I do the same. From 2, I take the horizontal, the vertical line till I hit this picture you have. This point right here, so this is f of 2. This point right here, the input, and the second coordinate is the output that corresponds to 2, f of 2. So whatever this is here, this is f of 2. Okay, so that's how the rule is given when you have a graph. So for example, let me ask you a question. Suppose I call this C, a symbol for any input. And I go and hit my curve right there. What's the coordinate of this point? What's the first coordinate? Alicia, I think. Alicia Water, What's the first coordinate? Okay, I won't push you. Sage, what's the first coordinate?
-2.
No. Look at the graph. What's this?
C.
C. What's the first coordinate?
Oh, C. Sorry.
Yeah, that's all right. That's okay. That's C. What's the second coordinate?
It would be the distance between C and that point on the graph, so f of C.
Right, that's f of C. That's how the graph gives us the rule, by taking the vertical distance from here to here. Now, what's the domain in this particular picture? What do I mean by domain? What are the input values in this problem? What do we mean by input value? If I tell you what is f of -3, it doesn't make sense, because if I take the vertical line, I'm not touching this little curve. So -3 in this scenario is not an input value. What are the input value in this problem? It are all the values for which I can find when I take the vertical distance, I can hit the curve. So in other words, in this domain, the domain are all the values of x, which are between -2 and 5. This is my domain here, because if I give you something which is less than -2, larger than 5, there is no graph here. It means there is no output. That's really my domain in here. Okay? So that's what it means for a function to be by a graph. Now I'm going to take, of course, a bunch of examples, a lot of examples to understand this picture very well. So before we do our worksheet, I'm going to give 2 more examples. Sometimes the graph consists of like bunch of scattered points. So example number 2. Okay, I'm going to ask you the following. The graph of a function f is given below. I'm going to ask you some questions. So I'm going to graph it with you, so in case you're taking notes, so it will not be hard. And this time I'm going to be, so I'm going to put -1 here, 0, 1, 2, 3, and 4. And always on the horizontal is where the input are. This is the input value. Very good. Now, and I'm going to put in this time, I'm going to put 2, 3, 4. So I'm going to put scale as well to make things a bit easier now. And -2. This is my scale. And this time, this is my graph. Bunch of dots. Don't be afraid of dots, because they are dots. A dot. And a dot right there. And this one is here. Okay, that's my graph. All right, so this time, this is my graph. It's a bunch of points. Okay, question number 1 is, what do you think the domain is in this particular problem? What are the input values for which we can find an output? So my graph here really consists of a bunch of points. What does this mean? So before I actually ask you about the domain, let me change my question. What is f of -1 according to my graph?
1.
1. F of -1, I take the vertical distance. This is 1. What is f of 1? No, what's f of 0? Quickly.
3.
3. This is 0. That's my dot right there. It's 3. And let's see one more. What is f of 4? Very quickly.
-1.
-1.
-1. Very good. Now, question number 2. Find all values of C. Find all values of C such that f of C is equal to 1. What am I asking for now? What am I asking for? What am I giving you? What am I asking for?
So you're asking us for all the values in the domain that give 1 as its result, which are -1, 1, and 3.
Yeah,
of this
so
graph.
here I'm asking you for all the values in the domain, for all the input. So I'm asked so that the output is 1. So I'm asking you which input, the same question, I want all of them. Which input will go to an output of 1? Now I go back to the picture, ask myself, okay, I want this 1 to be the output. What are the input? So I kind of draw a line to help me a little bit focus. And I realize that -1, F send it to 1. 1, F will send it to 1. 3, F send it to 1. So I've asked all the C such that F of C equal to 1 is going to be -1, 1, and finally C equal to 3. Okay. Now my last question is, what's the domain of this function? Means what are all, what?
-1 and 4.
No,
-1 to 3.
-1 to 3.
Actually, wait, no, 4 actually does have one. Yeah.
Yeah. So let us be very precise. Is 1/2 in the domain? In this particular scenario, in this problem, is 1/2 in the domain? It means, sorry, 1/2 is here. It means, is there an output for 1/2 according to my graph? Yes or no? Means if this is a half here, right? Am I giving you an output for it? No, because I don't have something. I don't have anything here. So if I tell you find F of 1/2, you should look at me in the face and tell me, okay, if I take this vertical distance, I'm not hitting anything. I'm not hitting the graph. So in this particular scenario, 1/2 is not in the domain. Is 1 in the domain? Yes. Is 3/2 in the domain? So what are the value in the domain exactly? What's the domain? Okay, so as you guys said, the domain here consists of a bunch of points. -1 in this particular problem. 0 is in the domain, 1 in the domain, 2 in the domain, 3 in the domain, and 4 in the domain. So the domain consists of 1, 2, 3, 4, 5, 6 numbers, which are those numbers you see. Okay. All right. One more example is the following. And now my question is, example 3. My question is the following. Is the graph below, so I'm going to draw a picture. Is the graph below the graph of a function? Means, so I'm going to sketch a graph. Okay, and okay, so I'm going to put a bunch of values, 0, 1, 2, 3, for example. Okay, and I'm going to put a bunch of dots, and why not? Okay, so that's my graph. And is this the graph of a function? Yes, no, justify.
No, because one can have more than one output.
Exactly, no, because 1, if I tell you what's the output that corresponds to 1, you have to take the vertical distance till you hit the picture I gave you. But now you hit it in 2 different points. You hit it here and you hit it here. It means there are 2 outputs for 1. No, because we have 2 outputs for 1. As simple as that. So if you have a graph, it's very easy to see whether the graph represents a function. You just ask, okay, is there one input? Remember, all the input are on the horizontal axis. Is there an input that has 2 outputs? And we start thinking, is it possible? Okay. All right. Now what I would like you to do is, I want you to go to Brightspace, and I have a worksheet, and we're gonna start working on it. We should be at least able to finish the first page. So go to Brightspace like last time, okay, and look for worksheet for section 1.3, all of you. I'm going to also put it in front of us, but sometimes students have a hard time seeing this. And we're going to do the first problem. Okay, did you guys pull it up in case it's not very clear on my screen?
Yeah.
All right, and now I'm going to ask questions for different students to answer those. So this is the graph of a function right here. So the graph finish here, the graph finish here. So I'm telling you how the graph finishes. And it's a graph of a function. And I'm going to ask you a question, f of -3. And I'm going to pick the student arbitrarily. Olivia. Olivia, are you with me?
Yes.
Go ahead. What's f of -3? What do you think it is? And then I will justify because I actually don't know.
F of -3 would be 10.
10?
Yeah.
Okay, let's see. This is -2. So
-5.
okay, this is -3. So this is -1. This is -2. So we have 1, 2, 3. So -3 is right there, right? Are you with me?
Yes.
And I have to take the vertical line till I hit the graph. This point right here, this is the -3, f of -3. Okay, till I hit the graph. So now I find the coordinate of this point. What's this point here? This is 5, 10. What this should be? I can't, is that confusing? So what's f of -3? Olivia?
12.
12. Okay, so you take at -3, you go all the way up till you hit the graph. And then once you hit it, you ask yourself, okay, what's this number here? This is 12. So f of -3 is 12. F of 0, Matthew. I hope I have one Matthew in class. Okay, Matthew, are you with me? Okay, that's fine.
Yeah.
Matthew, are you with me?
Yeah.
Go for it. What's f of 0? And then I'll explain it. Again, what is 0? That's 0. What is f of 0? From 0, you take the vertical line till you hit the curve.
Is it -3?
-3. That's f of 0 from here to here. So this one is -3. We keep going. Matthew, stay with me. What is f of 1? Remember, 1 is the input here. The input values are on the x-axis. Crucial. The input are always on the x-axis. So 1 is right there. What is f of 1? Matthew, stay with me.
Is it -4?
-4, I don't know. From 1, I'm going to take the line till I hit the curve right there. And now what's the coordinate of this point? I go here. You're absolutely correct. This is -4. So this point here is 1. That's the input. And the second coordinate is the output that corresponds to 1, -4. So -4 for us is the output. That's how the function is defined. That's f of 1. Now, f of 2, Nick, your last name is a bit hard. Nick.
It's Vitro.
Okay, Vitro.
Wouldn't it be 3? Or I'm sorry, I mean -3.
-3, is he correct? 2, that's the input. It is right there on the x-axis. And then the output from 2, I go all the way down till I hit the picture. And ask myself, what's the value here? This seems to be -3. So this point, so let me mark it very clearly here. This point here, this point is, 2, that's the input, and -4. But -4 is by definition of a graph. This -4 here, that's really the output. So this is the f of 2. Okay, so f of 2 is equal to -4. Drop B because I don't want to confuse you. Forget it. Sorry about that. C, find all numbers C such that f of C equal to 0. Sorry, drop number B. This is easy, but it confuses you. I don't want that. Find all numbers C such that f of C equal to 0. What am I asking you to find this time? Input or output value?
The input values.
Right, that spits out what kind of output?
The 0.
Yeah, so 0 is my output now, and I'm asking you which are the inputs. There may be more than one, which are spit out at 0. That's really my question is. So now I go back to my graph. I want my output to be 0. That's 0. So the output is here on the vertical axis. And I start, okay, which are the inputs which are giving me an output of 0? So this is my 0 here. Which are the inputs? Okay, I give you like, I don't know, 30 seconds to figure it out, and I'm going to pick one of you. Okay, I give you 30 seconds and I will pick one. I want each one of you to look at it. Which input you think their output is 0? It means the output is here somewhere. Jake, Ryan. Jake, are you with me?
Yeah.
Yeah.
Okay, so I got -1 and 3 because those are the points where the graph crosses the x-axis.
Right. Those are the points. So -1, it crosses the x-axis, which means, what does it mean cross the x-axis? It means the y-coordinate is 0. Cross the x-axis means the y-coordinate is 0. So now I'm asking which point. So basically I'm asking which point, what should be the point here so that the output is 0? It means the output is on the x-axis. So it's -1 and 3. -1, the output is of course 0, and 3, the output is also equal to 0. So the two values are -1 and 3. Because if I ask what is f of -1, okay, you have to take the vertical distance till you hit the graph, but the graph already intersects the x-axis. So f of -1 is 0 and f of 3 is 0. D, find all numbers such that f of c is -6. And I don't want E, I want to drop that. I want the question to be clear. Find all the numbers such that f of equal -6. So here -6 is an output value. And my question is there anything where the output is -6? Don't be afraid of the picture.
In this case, unless there's a hole or something, it would be undefined, right?
Right, exactly. There is none, because if I want the output to be -6, I'm going to take my ruler and go back to the graph. I want the output to be -6. -6 is here. Is there any value of x? If I go here, this doesn't intersect the graph at all. So there is nothing that has for output -6 because it doesn't really intersect the graph. There is nothing there. So here, find all numbers such that f of 6 equal -6. There is none. There is absolutely no value because there is nothing. There is no axis such that when you find the output, you get -6 because the graph is not really intersecting this line at all. Okay. Now, what's the domain of the function? The domain, it means what are all the possible input value. Drop E. Okay, I should drop them. My apologies, but the point is to understand the graph, no more than that. What's the domain of f? It means what are the input that you can find in output for?
All real numbers.
Let us say the graph stops here. To
Oh,
be very
okay.
clear, let us stay, the graph stops here. It doesn't extend. And if I want it
Minus
to extend,
3
I
to
will let
5.
you know. So what are the domain?
-3,
-3.
-2, -1,
No,
0.
no, I will have I will have
Ah.
problems with that. Why?
Oh,
Because if you tell me -3, -2, are you including -2.5? Is it in the domain?
yeah, it should be in the domain in
Should
this
be,
case.
because I give you -2.5, you can give me the output for it. So it is in the domain. Are you with me? If I tell you 0.5, is it in the domain? Yes, f of 0.5 is right there. So what's the domain? Not only the numbers, -3, -2, everything between -3 and 5, everything in between. If I give you any number between -3 and 5, 1/2, 3/2, 5/5, 3/4, everything will be in the domain. So the domain is going to be all real numbers between -3 and 5. Okay. All right. We're going to do another one along this line because it's very important that you have a full, totally full understanding of that. So we're going to all turn the page, all of us. Very good. And we're going to do another problem along the same line. And I'm going to ask more student questions. All right. Again, I'm giving you a graph. And I'm going to ask questions about the graph. F of -1, f of 0, and f of 2. I give you 30 seconds to do it yourself, and then I will pick one of you and ask what you got. You ready? Okay, let me see. Kyle Schwark. If I don't pronounce your name correctly, please don't take it personal. It's my problem, not yours. Okay, so Kyle Schwark, please go ahead. What's f of -1? The -1 is an input.
1/2. Negative 1/2.
-1/2. Why? Where is -1? Let us see the scale. This is -2. Where -1 should be? Right there. Am I right? Am I right, guys?
Yeah,
Okay, so what's f of -1?
0.
0.
0. Okay, what's f of 0? Kyle?
0.
0. What's f of 2?
6.
6. So from 2, I hit the curve. Right there. It's 6. Very good. Now, question B. Find all numbers C such that f of C equal to 3. Again, I give you 30 seconds to do it. Then I'm going to pick one, and I want to see what their answer is. This is very important. I want all the C's such that f of C equal to 3. Okay. Let's see. Okay, Ricky. What did you come up with? First, what am I asking for? An input value or an output value? Can you answer? Let's read it again. Let's read it again. Find all the numbers C such that f of C equal to 3. This 3 here, what does it represent? An output or an input?
Output.
Output. What am I asking for?
C.
C. Is it an input or an output value?
Input.
Input. So I'm asking for all the input that are sent to C. Okay. Now, can you tell me what did you get?
Um,
And then
negative
negative
1 1/2.
negative 3/2 or negative. That's what you got. Am I right? And what else?
And 1.
1. Okay. Let me check. I didn't do it myself. I let you do it and then I check your answer. All right. I want the output to be 3. So I'm looking for, this is 1, 2, 3. So this is 3 for me. And I want all the input which are going to 3. So basically I'm going backward. I'm really going backward. So this is my 3. And then I go backward. So I go this way till I hit the graph. So really I'm moving backward this now. And this is my 3 and I'm hitting the graph here and right here. And then I ask myself, okay, what's the input that, as you can see, I'm thinking backward. So I'm getting a 1. So his 1 is absolutely correct. And what's the other input that's taking me to 3? This one here. Okay, so minus 1.5, I will say if this is minus 1, this is probably more minus 1.7. Okay, because it's falling right in there. So I will change that. So you were approximately to minus 1 point. The students are telling me 0.75, and I think they are right because, sorry, this is minus 1, this is minus 1.5, we're somewhere in the middle. So it should be like minus 1.75. Okay, so this is my output of 3, and then I go backward and I look for those inputs that are bringing me an output of 3. Very good. Find f of 3. What am I asking for now? An input or an output? Let me pick another student, Aiden Campbell. Aiden, can you hear me? Yes, you can. Go for it. Am I asking for input or output in part C?
You're looking for the input this time?
Read the question again.
Oh, no, output, sorry.
Right, because 3 represent what here? It's between the parentheses. That's the input. And I'm asking you, what is f of 3? Because now I'm asking you, f sent 3 to where? Okay, that's what I'm asking this time. All right, what's the answer?
1 second.
Okay, stay with me, you guys. Don't try to lose me.
Like, it's at that weird bump where it turns from a curve into a line. So like, I'd say that's like 5.25.
So this is 3 here then, right? Am I right? So I'm
Yeah.
gonna go from here till I hit the curve. I'm hitting it right there. Okay, this is f of 3. So I would say 6.
Oh, I was looking at it the way that the other ones were like fractions. I didn't realize that it went straight to 6 after that one.
Okay, so but you see it now. I mean, all of you. So this is my 3. I take my line all the way till I hit the curve. And whatever the coordinates, so this is the 3, that's my first coordinate, and my second is f of 3, which is 6 according to the picture. Okay, that's really what it is. Finally, before we let go, find all numbers C such that f of C equal to 0. Go back to picture. I want all the C such that f of C equal to 0. Again, 30 seconds, and then I'll ask one, and I'm out of time, I think. So Esmeralda, I want a quick answers.
0.
You're with me? Okay, all the numbers at f of, so now what am I asking for? Input or output?
You're asking for the inputs?
Yeah, that gives me which output?
0.
Yeah, so which ones goes to 0? So back to the picture. So what did you find?
0.
Is it the only one? Because here I'm asking all. So I want all of them. So is this the only one?
Oh no, and -1.
A -1, exactly. 0 is 1, but that's where they intersect the x-axis, and -1. So both goes to 0. So c equal -1 and c equal to 0. Okay, very good. All right, so that's it for today. For next time, your homework, I will assign homework from the book, and I want you to finish the worksheet. So I'm going to assign practice problem from the book, and I want you also to finish the last problem. And your first quiz, if my memory is right, which is usually, is going to be next Tuesday. You're going to have the first quiz, and it will cover everything I did Tuesday, and I did today. All right? Any questions before I let you go? Yes, Danielle? Because I thought you were raising your hand. Okay. Anybody else? Any questions before I let you go?
So the homework is number 3 from the worksheet we were just working on.
And I will also assign practice problem from the book. And you guys know where the problems are. You go to content, practice problem, and that's where you find the problems. All right? Any other questions? Anybody else? Okay, enjoy your last long weekend before spring break, and I will see you on Tuesday. Bye-bye, guys.